In this video we're going to start looking at graphing exponential functions, and we have two categories. One where the base, this part right here that's being raised to the power, the base, is bigger than 1, absolute value, and then the category where the base is fractional, so fractional between 0 and 1 to be more specific. So let's take a look. They have several things in common, and we will be tracking these specific anchor points each time when we're graphing transformations. So when the base is larger than 1, we'll use the point 0, 1, and the point over here 1, b, where b is the base, whatever the base is. If the base is 2, this y-coordinate is 2. If the base is 3, this y-coordinate is 3. And they all have 0, 1. Okay, and let's think about why that's true. So when x is 0, that would be raising the base to the 0 power. Well, that's always 1, so the output is always 1. That's always true. It doesn't matter what this base is, as long as it's not 0, of course. We can't raise 0 to the 0 power. But regardless of what the base is, you raise it to the 0 power, it's always 1. So it produces an output of 1 no matter what. And the same thing is true here. If we raise the base to the first power, in other words, this x right here is 1, you raise anything to the first power, it's just that thing. So if the base is 2, it's 2 to the first power, that's 2, etc. So that's why the output here will always be whatever the base is. So we'll use those anchor points. It also has a horizontal asymptote of y equals 0 here, right on top of the x-axis. It never touches or crosses the x-axis there. And the domain is negative infinity to infinity for all of these. That's what it starts with, and range is going to be from 0 to infinity. Now, as we transform these, the range will shift as we move them up and down, for example, as will the horizontal asymptote, as will these anchor points. And notice that range does not include 0, so we put a parentheses there for that. Okay, now for the parent function where the base is between 0 and 1. So similarities, yes, but it actually goes in the opposite direction. By the way, this one is called exponential growth, and this one is called exponential decay. So this one has this rough shape like this, and this point is still going to be 0, 1 always, but and it also has the point 1, the base over here, but the base will be a fraction, so we usually don't use that one. We'll actually use this one, which is negative 1, the reciprocal of the base, so 1 over the base. So the easy way to say that is negative 1, reciprocal of the base. So if the base is 1/2, the reciprocal of 1/2 is 2, so it would be negative 1, 2. If the base is 1/3, the reciprocal of 1/3 is 3, so it would be negative 1, 3. But we'll see that later on. All of this stuff is actually the same over here. It's the same for both of these, so we won't write that again. Alright, let's look at some examples. We're going to start the transformations now. So the first thing we'll notice is this base is larger than 1. The absolute value is larger than 1. So it will have this rough shape. And we want to track those anchor points, so what I teach students to do is make your original table with your original horizontal asymptote and then put the transformations with it. So we'll make an original table, and then you can label it transformed or new. I'll just call it new after the transformations are done. So the original, this base is larger than 1, so it always has the point 0, 1 and 1, the base. Well, the base in this case is 4, so the original would have 1, 4, and it would have a horizontal asymptote of y equals 0. Alright, now apply the transformation. So let's look at what's happening here. So this part right here, the x plus 2, the plus 2 is with the x, so it's left and right opposite of the sign. So that'll be a left 2 that will apply, and then this is down 5. So we need to apply those changes. These are basic, so we're just going to write them down, and it's pretty easy to apply those. Later on, we'll start identifying what's happening to x and what's happening to y separately, because they'll get a little more complicated. But on this one, it's pretty straightforward. So left 2, that means the new x-coordinates need to go left 2. So the first x-coordinate will be -2. The second x-coordinate will be -1. Okay, now for the y's, they're down 5. So we're starting at 1. We go down 5. That takes us to -4. Here, we're at 4. We go down 5. That takes us to -1. And then the horizontal asymptote gets moved up and down. So in this case, down 5. So it was at y equals 0. Now it's at y equals -5. So now we have enough to make this sketch. So sketch our coordinate plane in there. Have a horizontal asymptote down here at y equals -5. So that's -5 there. And then we have the point -1, -1 right here. And we have the point -2, -4 right here. So this one looks something like this. And we'll label these points. This was -2, -4 down here. And then this point right there was -1, -1. So we always want to label those anchor points. Alright, so let's look at example 2. Example 2, this one's also pretty straightforward. The base is larger than 1. We will make our original table and our new table here. So the original table always has 0, 1 and 1, the base. The base is 2, so there we go. And the original horizontal asymptote is y equals 0. So the new table, let's look at the transformations. This one's pretty easy. It's just up 3 only. That's the only change, so up 3. So the x's will be the same. So 0 and 1 for the original x's and the new x's. So now for the new y coordinates, we need to move them up 3. It was at 1, move it up 3, it's now at 4. Was at 2, up 3, now 5. And the y equals 0 was the horizontal asymptote originally, move that up 3, so it's at y equals 3. So that's all that we need to graph this one. So we'll put our coordinate plane in there, put our horizontal asymptote in at y equals 3 here, plot in our points at 1, 5 right there, and 0, 4 right there, and plot that in like this. So that looks like that, and this was 0, 4 was the lower point, and the higher point was 1, 5. So that's it for that one. Okay, now they get just a little more complicated here with more things going on. So we're going to make a table or a list of what happens to the x coordinates and what happens to the y coordinates to help keep it straight. So we do notice that we have a base between 0 and 1, so the original shape will be down like this, so we need to keep that in mind. And we'll start with what is happening to x. So the only thing that's happening to x is this part right here, so that x plus 1 is left and right opposite of the sign, so that'll be left 1. So that's it for the x. Now the y has several things going. We're going to multiply it by -3, so it makes it opposite. The signs will change, and they're multiplied by 3. We can accomplish that all together and just multiply by -3. So I'm going to abbreviate multiply by -3, put that in parentheses, and then this out here we'll move them up 2, and we'll use order of operations to do this. So we'll multiply the original coordinates by -3 and then add 2 to them, and then that's going to be it for this one as far as the transformations. So we'll make the old table. Okay, so the old table would be -1, 2. Remember, this has a base between 0 and 1, so we use the point -1, reciprocal of this base. So you take the reciprocal 1/2, that's 2, pair it with -1. So -1, 2 would be the original, and then it always has the point 0, 1. Alright, and then it has horizontal asymptote y equals 0. So now for the new table, so we need to make these transformations. The x's are just left 1. So we were at -1, you go left 1, that takes you to -2. Let's go ahead and do this x coordinate. We go left 1, we were at 0, so that takes us to -1. Alright, and then for the y coordinates here and here. So we need to multiply by -3 and then add 2. So we start with 2, we multiply it by -3, that takes us to -6. Then we move it up 2, that takes us to -4. Alright, so again, multiply 2 by -3, that gives you -6. Then move it up 2. From -6, you go up 2, that takes you to -4. Same thing here. Multiply by -3. So 1 times -3 is -3. Move that then up 2. That takes you to -1. So we have the points -2, -4, and -1, -1. Also, the horizontal asymptote moves up and down. The multiply by -3 doesn't change anything for that. Just the up and down movement moves the horizontal asymptote. So up 2 would take it to y equals 2. So, kind of running out of room here. Let's do that coordinate plane here in black. Here, like that. Put the horizontal asymptote in at y equals 2. And we have the point -2, -4. So -2, -4 down here. And -1, -1 right here, like this. And normally it would have been going like this, right? But the multiplying by that negative makes the y's opposite, so it flips it and makes it go like this. Okay, so we have to approach the horizontal asymptote, and based on the shape of these points, it has to go this way. That was the only possibility. It couldn't go any other way than that. So if you put your points in right and your horizontal asymptote in right, then the graph shape will work itself out. Alright, so let's move on to, let's label these points real quick. -1, -1 there, and -2, -4 down here. And then this horizontal asymptote was at a y value of 2. Alright, let's go to example 4. Alright, example 4, I've gone ahead and got our list started for what's happening to x, what's happening to y. We actually want to rewrite this one because they have this negative in front of the x. We want to factor it out so that we can apply our standard rules. So we factor out that negative in front. I want to write that a little lower so I'll make sure it all fits. So we have the negative in front, we factor that out, and this becomes a subtract 2 inside. And then we have the plus 5 down here like this. So f of x equals. Okay, so if you distribute the negative in, you get -x plus 2, and that's exactly what they had in the beginning. But now our rules apply. So this makes the x's opposite, this moves them right 2, this will move it up 5. So those are our changes. So for x, they're opposite signs, so we'll flip their signs and then move them to the right 2. And that would be the order of operations. We have to multiply by -1 and then add 2. That's what we're going to be doing to the x's. And for the y's, just this plus 5 right here, we'll move it up 5. So those are the only changes. So let's make the old table the new table, and then we'll graph it. So the old table, notice again the base is between 0 and 1, so we'll use the point -1 comma reciprocal of the base, so -1 comma 3. The reciprocal of 1/3 is 3, and we always use the point 0 comma 1. And now for the new table, we'll make those changes. So the x's are opposite sign and right 2, so make this opposite, it becomes +1. Move it to the right 2, it becomes +3. Now the y coordinates are moved up 5, so from 3 up 5 takes us to 8. So that gives us the point 3 comma 8. Over here, make the x opposite, so the opposite of 0 is still 0. Right 2 takes us to +2. Then for the y coordinates, they go up 5, so we were at 1, go up 5, that takes us to 6, so 2 comma 6. We did have y equals 0 here. So now we'll have y equals 5, so we move it up 5. Alright, so we have horizontal asymptote at y equals 5, points 2, 6, and 3, 8. So now let's make that sketch. Right here. So we have 2, 6 right there, and 3, 8 right there, horizontal. asymptote of y equals 5 right across here like this, and that means it's shaped like that. Label those points 3, 8 and 2, 6. And that is it for that one. So we'll stop this video here. We'll make a part 2 with the remaining examples.